everyone. I'm John Furrier here in theCUBE in our Palo Alto studios. We're here breaking down the latest news on DeepSeek and the impact to the industry, and it's all everyone's been talking about for the past 4 days here in the technology world. Hagay, he's here. Lupesko is with the SVP of AI Cloud at Cerebras. Hagay, thanks for coming on, and psyched for your time as we unpack the impact of DeepSeek and what it means for the industry, and of course, what it means for faster AI and road to AGI, as everyone is speculating. So thanks for coming on.
Hey, John, thanks for having me.
So first of all, I was tweeting a lot about this and commenting on LinkedIn. And I love when I see innovation that moves the needle in many areas. There's so many storylines. Some are misrepresented. Obviously, we saw a lot of the commentary. But I think what was jumping out at everyone was, wow, you can actually do some algorithmic tuning with software to make the hardware run faster. And then on the hardware side, you're seeing that innovation. You guys have been doing it at Cerebras with the chip. We've featured you guys at supercomputing. So you kind of see the confluence, the intersection of faster AI infrastructure now with software tweaks, algorithmic tweaks. The levers are being pulled. So I'd love to chat with you about the DeepSeek. First of all, what's your takeaway, big picture, on the DeepSeek impact?
Well, I think DeepSeek has a pretty significant impact on multiple levels. One of them is efficiency. The other one, which arguably is much larger, is reasoning. And in AI, when we talk about reasoning, we refer to really the set of techniques and algorithms that really take more compute and more time and then produce much better model results, model output. And more intuitively, it's really about taking more time to reflect on the problem at hand and come up with solutions, evaluate them, verify, and come up with a final answer. Now, I can't overstate how important this is for the field. It really unlocks the next step function improvement in artificial intelligence. We were approaching a glass ceiling with our current approach to AI, which was a lot of it was about just scaling the models to be larger and larger. And it worked quite well for some time, but we started seeing really diminishing returns, I'd say, in the last year or so, which in AI terms, that's a very long time. And reasoning is really this fresh new approach that allows us to really make the next major improvement in the field.
Yeah, I saw a bunch of memes out there, certainly, with all the logos. No reasoning, a little bit of reasoning, full reasoning. So like a lot of conversations around who actually has reasoning working well. And obviously DeepSeek kind of facilitates that conversation. So I have to ask you, how was DeepSeek able to build a better reasoning model than, say, OpenAI and others? Was it the time that they jumped into the game? Was it the pre-existing work that was done? What's your take on this? Why were they able to start getting down this road of reasoning with the scale and the efficiency so fast? And doing it better than, say, OpenAI?
Yeah, I would say DeepSeek, the company, the team, definitely deserves a lot of respect for the work they did. They delivered an impressive milestone with their launch, the recent launch of the R1 model. But I'd be careful in crowning this as better than OpenAI. I think the landscape is a bit more nuanced than that. OpenAI today has multiple reasoning models, O1, O1 Mini, and more recently O3. And there are different ways to try and compare the models. You have different benchmarks in different areas of math, science, coding. And even these benchmarks are only proxies to the actual quality of the model. Overall, what I would say is that DeepSeek R1 is on par with OpenAI's top models. And it's great to see the ecosystem evolving and having more players that offer top-notch reasoning models. I think DeepSeek definitely, for those that are in the field, it's not a big surprise. DeepSeek has been producing great research and great models for quite some time. And I think what's really awesome is if you read their technical reports that they've been publishing, it really opens up the path for other companies, other organizations to build on top of that. And in that way, it's very similar to what Meta has been doing with their Llama Foundation models. They've been doing fantastic open work that allow the industry to build on top of it. And I would guess that DeepSeek themselves have built on top of what Meta has been doing. And now with DeepSeek contribution, more players in the community can build on top of that. So it's really a win for everyone at the end of the day.
Yeah, there's so many threads here to pull on, and it's kind of fun to see the level of kind of action. When I was kind of scouring the web and looking at reactions from experts, founders of other companies, and just overall general reaction, it kind of falls into three buckets. And I want to get your reaction to this, because I think there's a landscape impact to the AI market, certainly with the open model, is kind of connecting three areas. One is app developers that are doing either AI apps or being producers of AI or building apps that consume AI. So the app developer market is in a frenzy. Number two, this AI lab systems build out kind of section, people who are thinking about building large scale systems and or whether it's in the cloud or on-prem. They're looking at what this means for them, whether it's the mixture of GPUs, compute, XPUs, NPUs, all these things are now kind of under design. Like, okay, I'm playing with this design. So I call that kind of the builders, platform builders or systems builders, kind of a systems architecture. And third is this domain expertise area, people who have expertise, whether it's data sets or whatnot. So you kind of see three common themes emerging in the commentary. What's your reaction to that? Do you agree? Am I missing anything? Because if you think about the open source piece of this, I mean, that's going to feed the developers, right? So that's also going to trickle down and affect some of the data modeling. That's going to affect then how systems are built. And Cerebras is in the middle of being the mother chip, I call it, the Ferrari engine of AI with the speed. So you guys are kind of sitting in the periphery of all those. What's your reaction to that, and any thoughts?
Yeah, I think the way you're thinking about this three-tiered system, app developers, platform builders, and then really the infrastructure layer, that I think is very reasonable. And I think one other thing to highlight is there is the users on top of all of that who consumes all of that, those applications, those AI capabilities, and they're the big winners actually out of all of this, because the more we have AI infused into the applications that we use, the systems that we use, the systems that power the things we do day to day, things are going to become more efficient, faster, and really just make humans much more productive across the board. This is really the big winner out of all of this. I think the work that we're seeing here from DeepSeek is actually going to power all of these three tiers that you highlight. A lot of it is thanks to the fact that this is open research. These are open models. It really allows the entire ecosystem, app developers, platform builders, and then the infrastructure layer as well, to benefit from that leverage and also build on top of that. So that's very exciting to see.
Yeah, I think, and that's a good point. Let's talk about that concept of open, because a lot of the initial knee-jerk reaction was, oh my God, they're Chinese systems. But not really. I saw the CEO of Perplexity and others say, hey, you can just take the model and run it on-prem, right? Like this is not tied to that. Talk about that concern and why that's not an issue.
Yeah, so I think what we have here is a model built by a Chinese firm, trained, and then made available publicly. Now, of course, the techniques, the data used to train the model, that's kind of obscure, but that's not actually very different than other companies who are building models. It's very common for these companies not to share much about the training data. But then at the end of the day, this is an open model. So the model architecture is available for anyone to see. The model weights, which is really the output of the training, is available. And it's really up to any company out there to evaluate the model, try it out on their business use case, and make the decision whether they're okay using it or not. So I think overall, again, it's kind of a win for the community. I definitely think some companies and organizations may choose not to use this model because they may have concerns about the data that was used for training. Again, that's not very different than other frontier models that are closed. And many other companies, like you quoted Perplexity and many others, would definitely be interested in trying out the model, and if it works well for their use case, to use it.
I saw that you guys launched DeepSeek R1 Llama, with inference. You guys are playing with it. What's your experience? And obviously the speed, we'll get into that, but I want to just get first your experience with taking it and running it.
Yeah. We do have the model available on the Cerebras inference platform. Our experience so far and the experience of some select customers has been very positive. The model is relatively compact in size, which is great for the speed of inference, for the cost of serving. And then on the other hand, has fairly high quality output. Typically, I'd say surpassing models of similar size. And a lot of that is thanks to what we mentioned earlier, the reasoning capabilities. For some problems, such as complex math problems, problems that require more planning and reflection, that model definitely works much better.
Talk about the speed and the relationship to GPUs relative to kind of how people have been thinking about deploying. You guys have such a step function speed advantage with Cerebras, how you've done it. I've talked to others and they've said, hey, I can have a bunch of GPUs, but I don't need to go all GPUs to do all this other stuff. I can use these models in kind of a distributed framework, whether that's a power envelope issue or whatever. Talk about the speed and then the relationship of how to deploy this for customers who are looking at, cost and performance, because I think this opens up the conversation, speeds and feeds, but also cost of ownership. What's your thinking around this? How should people be framing this? It's not a replacement for GPUs, or is it? How should people be thinking about this from a deployment standpoint and as they roll out the systems?
Yeah, I would start by actually asking, does speed matter in AI? And the answer is it definitely matters for some key use cases. There are two main trends going on in AI today that are unlocking a lot of value of using AI. The first one is what we mentioned earlier, reasoning. Because with reasoning, you are able to solve much more complex problems that are so far pretty difficult for AI models to handle. The second one is agentic AI systems, which is kind of emerging as the blueprint for companies to build AI systems. And agentic systems, typically a system where you have multiple models that are able to use tools like invoke APIs, things like that, as part of the system operation. And that also tend to have higher latencies in terms of handling a task, because as you can imagine with agentic systems, you have the request being handled by different models, they invoke APIs or use different tools. So it takes a bit more time until the end user gets a response. So for these two key use cases, speed is key. And I'm talking about the difference between when you run on GPUs, response can come back in over a minute, which is a fairly long time, especially if we're talking about an interactive application. Whereas on Cerebras, thanks to the speed, this can be done in seconds. So speed definitely matters in modern AI and can unlock a lot of value and use cases. Now, when you look at Cerebras hardware versus GPU, I'd actually start by looking at GPUs. And many people don't remember, but GPUs actually started as accelerators for gaming. GPU stands for actually graphical processing unit. That's the origins of GPUs, and today they're used both for gaming and for AI. But it's important to remember the original design of GPUs more than 20 years ago was really about how to accelerate graphics rendering. Now, we were all lucky that this turned out to be useful for modern AI, which is neural networks, because modern neural networks require a lot of matrix multiplication operations, and for graphics processing, you also need to do similar operations. But then these processors, GPUs, were not designed from the ground up for neural networks. So you still have a bunch of bottlenecks and things where it's not optimal. Now, I'll contrast that with the Cerebras hardware that was designed from the ground up for modern AI, for neural networks. It started actually with the emergence of neural network. So the whole design factor this in. You can, I wouldn't recommend using Cerebras for graphics processing, for gaming, but for AI, it's definitely kind of addresses a lot of the challenges and bottlenecks. It's a massive chip. It's 50 times larger, packs 50 times more transistors, packs 700 times more memory and 7,000 times more bandwidth between the memory and the compute. And actually, the compute and memory are co-located on the chip. Now, what this all gets us is just immense speed in running inference for neural networks. And the larger the model is, actually, the more that bottleneck, while it's painful on traditional GPUs, on Cerebras hardware, it's less meaningful. And that's how we're able to get out these massive speeds for modern AI, and specifically generating the next token. Cerebras does that 50 times faster or more than GPUs. And that's what also goes back to unlocking that value of using state-of-the-art models, reasoning models, agentic systems on top of the Cerebras hardware.
Yeah, I mean, reasoning is really important for getting into that agentic wave and then path to AGI, as people talk about, but the speed is huge. I mean, if I'm gonna have that car on the track and I'm racing, I want the best speed possible, and that's what everyone's trying to get with AI. So I want to be that Ferrari on the track and go super fast. I have to ask you, what applications are you seeing right now with this that would be notable? I mean, applications, what are you seeing emerging? And Andrew Feldman and I chatted about the chip and the history of it at supercomputing. You guys have, again, purpose-built this chip, but now that the world's spinning in your direction, what applications are we going to see out of the gate, and where does the reasoning go next? What are the next applications after reasoning that are going to really jump off the page from a performance standpoint?
Yeah. We are seeing actually customers doing a lot of creative things across the board. I really think AI is this horizontal technology layer, right? It applies to many business problems and many use cases. So we're seeing customers doing finance, financial analysis, pretty complex financial analysis. We're seeing customers developing agentic systems for financial analysis. That's one domain. We're seeing customers operating in the consumer space, building interactive chat applications for different tasks, actually, all leveraging the same capability, where models can actually reason about the context they're getting, come back with answers, summarize difficult topic, or answers questions about topics. We're really seeing the use cases coming all over the place. It's not just one specific vertical. And this kind of goes back to that point where really AI is this horizontal technology layer that is just infusing many different domains and verticals.
Talk about the reasoning model and the impact of kind of selecting my system. So I talked to a lot of folks and like, hey, I'm gonna have some compute over here. You have it built into the architecture. Okay, great. But as I look at my costs, I'm gonna have some GPUs, I got some compute. There's inference going on, there's a lot of reasoning, training was done. Do I actually need more compute for this? What's the impact to me if I'm a platform architect or system architect putting together my superclusters or my plans to have these AI factories or whatever you want to call it, building it? Does this allow me to do more compute? Is that going to lower the costs? Is the power envelope? So a lot of these decisions have a lot of levers. Yep. Do we need more compute? What's your thinking? What's your advice for folks thinking about this as they get their arms around this?
Yeah, I think what we're seeing clearly is to unlock more value with AI. Definitely more compute is needed. If we look at reasoning models, like I described earlier, the chain of thought that happens, the reasoning, the selection of different methods to solve a problem, the verification, all that means more compute, more processing, and that's what you need to unlock more intelligence out of AI. Yeah. With agentic systems that I mentioned earlier, it's the same. You need different models to collaborate, to choose tools to invoke, to understand requests, to process outputs. All that stuff, again, translates into more compute. So from what I'm seeing, really we have a massive need for AI compute specifically in inference, that is actually growing. And I suspect that the more we see mature AI-powered applications out there, yeah, like ChatGPT and like other successful applications out there, the more the need for compute will grow. And given where we're seeing AI progressing next, right, this path to AGI, reasoning is on that path for sure. We're already seeing it now. That's just going to mean, more compute.
So this is a perfect storm of innovation, I call it, because you got the software folks love this, right? The hardware folks love it. The systems developers love it because they're building these big systems. So all that's going on. Now, some might say, hey, you know, software is outpacing hardware. The era of relying solely on powerful chips is fading. When in reality, actually, the powerful chips are actually making the hardware and the systems better, which makes the software accelerate on the software side. So as people pull the levers, you got one lever on this side. How do I get more power out of how do I get more performance out of the hardware and systems with my power envelope? And then you got algorithms being changed and tweaked, lower cost, faster acceleration. How do you look at that? How should people be thinking about the innovation going on? Because I don't think that's the case, that we're relying solely on powerful chips. I think people talk about the GPU in particular, but what's your view on this? Because this is a software algorithmic kind of lever that's pulling fast. You guys have the powerful chip, but it's also in concert with other chips. Talk about that dynamic. How should people think about that? What's your perspective?
I would say it's definitely a vicious cycle. If I take an analogy of, cars and gasoline as an example, when you sell more cars, the consumption of gasoline goes up. When the price of gasoline goes down, people buy more cars. And so it's a sort of a vicious cycle. I think it's the same in AI. The better the model the more we're seeing applications that are leveraging these models to build fantastic user experiences and solve business problems. The more these applications are available, the more inference compute we need, the more training compute to train new models we need. Yeah. And then with more inference and more training, we get better models, which in turn creates better and better applications. So it really is a vicious cycle. I think we're just at the very early days of the application of AI in just our day-to-day lives. And just imagine what's going to happen when AI adoption is going to be 10x from now, 100x from now. Yeah. The amount of compute we're going to need to power all of that is going to be massive. Now, the more this compute is available, the more people actually build application, leverage AI. So this vicious cycle is already with us, but we're just getting started. So I'm definitely expecting more and better models, the need for more and better compute, and all of that is going to just translate into, building fantastic applications with AI that are just, more and more ingrained in our day-to-day lives.
Great to have you, Guy, on the program, because I think, the AI arms race, some are calling it, I've said that on the internet, it's the Cold War and this is going on, but put that aside, just in general, innovation is happening. But you've done talks, I've watched some of your talks on open systems and open ecosystems, open source specifically. With open source AI and distillation kind of redefining the industry landscape, this moment is here where scalability and efficiency matter. Not just about the size of the model, because that's going to be, I wouldn't say commodity, but changing and getting better. You're going to see leaderboard changes all the time on models. But the scalability and efficiency matters. So it's what's in the system. Can you share your thoughts on, as this innovation change happens, the shift, how important is the scalability and the efficiency? You guys are in the middle of it with a super big component of the systems.
Yeah, efficiency matters a lot, and would matter even more the more we see AI democratized, used in more applications and systems out there, right? So once we continue hitting peaks and peaks of massive scale, obviously efficiency would matter a lot. I would argue that it matters a lot even now. And we're seeing that with just the models we have available out there. We've been seeing very large models being made available for the community. But really, the models that are deployed at scale are those that are cost efficient, right? They have the right level of quality and the right cost to serve. So efficiency is top of mind, I think, for every application developer and also every system provider out there. And we need cost efficiency to really scale AI further.
Hagay, great commentary. I have to ask one final question because this is such a big news item. I know it's big when I have family members who aren't in tech calling me, what do you think about this DeepSeek thing? So I'm sure you're getting a lot of that too, being an expert, you got to wade in. So there's a lot of news out there, all these hot takes. How should the average person think about what DeepSeek is? And then how should the industry professional who's actually trying to make AI work for and build for their companies think about it? So, I'm sure you got these questions to you thrown at you all the time this past couple of days. What's your take for the average person? What does this mean? And what does it mean for the people really working hard to build out these systems and reasoning engines and agents and these new capabilities? Two points there.
Yeah, my recommendation, or the way I look at it, I think it's a fantastic incremental milestone for the AI community. Again, the DeepSeek team, which is a very strong engineering and research team, has made an important contribution. They open sourced their work, or they published technical reports that detail a lot of the techniques that they've been using. They made important contributions to efficiency. They made important contributions to reasoning, to reinforcement learning, fantastic contributions. They're actually, in my view, walking in the footsteps of Meta, who's been doing a great service for the community by open sourcing the Llama models, publishing great technical reports, and building PyTorch, which is the infrastructure that really all of that stuff is built on top of. So DeepSeek made important contribution. I think we should continue to explore it, learn from it, adopt it where appropriate, and build on top of that contribution the next innovation, which I'm sure will come. So overall, it's a net positive for the community and for everyone. And I'm personally looking forward to see more good stuff coming out of the DeepSeek team and more good stuff coming out of other major contributors to the community.
It's an important point you just made about open contribution. It's out there. It's all out for everyone to see. There's no ball hiding going on. It's out in the open. And the PyTorch mentions is interesting too, because if you connect the dots on how that happened, you can almost say, hey, this software layers will be democratized as well. So this idea of having proprietary software layers may be at risk as well. Moats that are out there that people are building around that. I mean, quick thought on that. I mean, this is a trajectory. It's a best practice.
Yeah. And we've seen that in software industry, right? Time and time again. Many new revolutionary technologies started as being closed and proprietary, and eventually have became open and non-proprietary and almost standards that are adopted. We've seen that with databases, which was at the time a revolutionary technology. We saw that with the internet, again, the same thing. And now we're seeing it with AI. It's a process. I do believe that it will end up being much more open than it is today. And I do believe it will be the best interest of everyone, all players in the field, including the end users.
Yeah. Well, while I got you here, one more final question since you're here. You're the SVP of the AI Cloud at Cerebras. Just quickly explain what that is, what's your plans, what's going on with the product, and how do you see that rolling out? What's the big breakthroughs for you and your plan this year?
Yeah, so at Cerebras, we've been busy building the world's best AI hardware. The company started with that mission about 9 years ago. As I mentioned earlier, really designed the hardware for modern AI, for large-scale neural networks. And that's been an exciting journey for the company. With our AI cloud, really are taking this hardware, which, as mentioned earlier, is demonstrating the best performance in the industry for large model inference, and just democratizing that across the board. So if you want to integrate state-of-the-art AI into your system, into your application, agentic system, or what have you, you can just very simply access our APIs and benefit from state-of-the-art hardware, the Cerebras hardware, powering all of this under the hood. We really focus on making it as easy as possible to get started and to use, not worrying about all the nuts and bolts of programming the hardware. We take care of that for you, and you benefit from the fastest inference out there. And of course, we also make sure it's highly reliable, highly secured. We have a zero data retention policy, meaning Your data is yours. We don't store it. We don't do anything with it except for running inference on your data. And we believe this is a great way, not just to get our hardware to work hard, but also to just, power a lot of new AI applications out there that would benefit from state-of-the-art AI. We are very busy scaling up our service. We're seeing a lot of demand. These AI use cases that I mentioned earlier that benefit from speed generate a lot of demand for us. The Cerebras inference, thanks to the hardware, is over 50 times faster than GPUs, which is a fantastic advantage for application developers who are building, interactive applications, reasoning applications, agentic systems. We're seeing a lot of demand. We're very busy scaling up our capacity to meet this demand. And then, of course, add support for great new models coming out of DeepSeek, out of Meta, and out of other players in the industry building open models. Yeah, we're excited about the future.
You guys are growing like a rocket ship. Congratulations.
Thank you.
Hagay Lupesko is here as SVP of AI Cloud at Cerebras. Again, company is extremely well, unique approach, delivering the performance. And I think as we get into more reasoning, that's when the applications are really going to start to sing and provide really even more value. Speed is key in AI, and of course, inference, reasoning, and the path to AGI. Thanks so much for watching. I'm John Furrier here in theCUBE in Palo Alto, breaking down the latest news and analysis on DeepSeek. Thanks for watching.